Okay, so suppose there is light coming from a particular direction and this is the direction. Okay, light is coming from this direction, and when I say light, basically photons. Now here we have got photons of many frequencies. You can see E0, E1, E2, E3, E4, so on and so forth. So suppose this light, and this is all happening in vacuum, outer space, there is very less material out there. Now suppose this falls on a gas medium, this light falls. Now what will happen? This depends on the material of which this gas is made of. Suppose, let us consider one particular atom inside this gas. Now it so happens that this, now let us look closely into this atom. So suppose it is that, so that this atom has an energy level like this. So this is some energy level 0, 1 and so on and so forth, and this is n. And it is so such that this gap corresponds to mu0. Then what will happen? Look over there, we also have this gamma 0, where its energy is h into mu0, right? So the frequency matches. So what will happen is that when all these photons will fall on the atoms, right, only this one will be absorbed because its frequency matches with one particular excited levels, right? And so what will happen is that this atom in its ground state will be excited to the first excited state, right? So one for first excited state. This will happen. Now what will happen after that? After that, what will happen is that after some time, depending on the lifetime of this level, this will decay. Now let us see what happens nearby. Now this light is coming, okay. So this light, which was initially coming in this direction, which comprises of say E0, E1, E2, E3 and E4. So 5 frequencies. Now I am assuming that all the E0s have been absorbed. So what will you observe in this direction? In this direction you will observe E1, E2, E3 and E4. No E0. Right? Any questions? No. So if I observe the intensity versus wavelength or frequency plot, what will we observe? Will we observe something where there will be a king, and this king will correspond to which one? Mu0. Okay? Something will be there, right? Now, so this is particularly the scenario on this direction. Now let us consider the overall. Now we are actually considering the gas medium, right? And I am just considering one particular atom. Now what will happen after this time, tau1, mean lifetime of the first excited state? It will be de-excited. Now when it de-excites, it's a random phenomenon. It will be de-excited in all directions, right? Here will also be there, all the directions, right? And what will you observe as a result? This, what you will see is only this frequency, mu0. Okay. So this is the difference. Now, can you tell me something over here? Suppose we are sitting over here. We are sitting over here on the earth. Okay. Now, so light is coming with all frequencies. It is being absorbed, and the absorbed stuff is being emitted in all directions. So the question is, why are we seeing this thing? because it is also emitted in this direction as well. So why should we observe the dip? বুঝতে পারছো? মানে আমি তো এখানে দেখছি তো এটা emit করেছে, it is not that it is going to eat away the energy, then why are we observing this dip in this particular direction? কেন?
কারণ সে যে ইন্টেন্সিটিটা নিয়ে আসছে আই নটটা সেটা সব দিকে ডিস্ট্রিবিউট হয়ে যাচ্ছে।
Very good. Say for example, suppose there are how many frequencies? 1, 2, 3, 4, 5. Let us consider 500 photons. 500 photons. 100 photons of each frequency. They are coming. Now, at this point, there are 400 photons, 100 from each of the 4 frequencies. But 100 photons of E0, they are being distributed in all particular direction. So very less will be there in this part. See, it is not zero. Important. This is not zero. So some part is also being absorbed over here, but it is obviously less than 100, and that's why you are observing that too. Okay. So this is the overall scenario for absorption and emission spectra. Here you are seeing nothing but just this line. Okay, and here you are observing a dip over here because of the absorption. So if you observe in this direction, you can say you are observing a starlight on Earth sitting over here, and in the solar spectra you observe in the intensity versus frequency plot, you observe a dip. What will you infer? You will infer that the starlight was emitting probably all the radiation. Consider the black body scenario. However, there was some medium in between the star and Earth, and this is the reason why we are observing this dip. Now it might so happen that we can observe several dips. Then from the frequency of the dip, you see, we can do molecular or atomic spectroscopy. We have done that, right? On Earth we have done all those stuff, and from the frequency itself we can say, without going into the interstellar space, what is the composition of the gas. How interesting. বুঝতে পারছো? কিছুই করলাম না, জাস্ট ডিপ দেখে গল্পটা বলে দিলাম কি হচ্ছে।
অ্যাটমসফিয়ারের সাথে তো একটা
ইয়েস, সেটাও হতে পারে, সেটা তো আমার জানা আছে। I know what is there in our atmosphere. The atmospheric dip is known to me, but this one is something different. I can calibrate all that stuff. বুঝতে পারছো? I can even do the experiment outside the Earth to reduce the effect of the atmosphere. ঠিক আছে? Precision measurements. Any questions? ঠিক আছে?